Hi, welcome to RAR Math. In today's video, I am doing an example of a sinking fund. So in other words, you know how much money you have at the beginning and you're paying it down to $0. Within this video, Jade buys a car. She has a down payment. She pays off her car in 60 months, but then we also know the question is how much interest will she pay? There's a lot of things going on in this problem, but I'm also going to add a little bit in that I want to show you how to use your calculator to calculate these, because sometimes the issue isn't the question alone or the setup, but how do I put this into a calculator to get the right answer? So this is really a calculator video. So if you know how to use your calculator, you might not want this video because it's going to be a little bit longer, so we learn how to use our calculator. The first thing we need to do is we need to take that $23,399.99 and subtract off the down payment, the $1,500. When you pay a down payment, often you get a lower APR. So what Jade actually pays in a loan, what she needs as a loan, is $21,899.99. At this point in the process, this number right here, that goes away. This number right here, it also goes away. You've used them. They're done. For the rest of the problem, we don't worry about that. This is the number we care about. So from here on out, this is the number we're going to use. When we're talking about knowing the money in the present and going down to zero, we use the present value of an annuity. Okay. So the present value of an annuity, P equals R. 1 minus 1 plus R over N to the N negative N T over R over N. This is our formula, but I'm going to note 60 months means that NT equals 60. We don't need to multiply the N times the T because N is monthly. T, we're not told how many years, but this is how car loans go. You're not told that this is a 5-year loan and then take 5 times 12 to get 60. You're just told a 60-month loan. That's how car loans go. And this is why it is set up this way. So we know that the car loan is $21,899.99 equals R. 1 minus 1 plus that 4.5%, 0.045 divided by 12 to the negative 60 over 0.045 to the 12. And to solve this, we're going to have to divide by that big old bracket of stuff. Some people get that bracket to a decimal and divide by the decimal. The problem is you're probably going to get the wrong answer because you will round. And every time you round, you're going to get an answer that's a little bit off, a little bit more wrong. It's not the best practice when doing a problem like this. You don't want to round. So what you do want to do is you want to figure out how to use your calculator. So we are going to take, I'm trying to figure out how to do this. I'm using a different calculator stand. I'm sorry for everybody for the earthquake that is about to happen as I move all of this down. I don't know if I can. I need a little more space. Okay, that should be enough. Whew. Okay, what I need to do is I need to take $21,899.99, and I need to divide it by. So if you've seen other calculator ones, I noted that you need a parenthesis for the numerator, and then 1 minus parenthesis 1 plus 0.045 divide 12 close parenthesis caret. Now you don't actually need a parenthesis for that -60 because it's not being multiplied. There's no computation there. It's maybe not the best, a bad practice to keep exponents in parentheses, just so you have that in a practice. Close off that numerator, divide by, there's computation in the denominator. So we're going to go 0.045 divide by 12, close parenthesis. Oh, that was a lot of stuff going on there. But when you type this into your calculator, you then get a wrong answer and you're like, why? This is such a weird answer. It is not correct. Let me show you. I'm going to use my favorite calculator, and anyone who's seen any of my videos knows that this little one is my favorite for an inexpensive calculator. It's my favorite. You'll notice up here it says complex. It's my favorite because I can put in the square root of -1, and sure enough, it'll tell me I. And this is not a very expensive calculator. Anyways, I can put in 21,899.99 divided by, and I can just put a fraction in. A lot of your graphing calculators have that. If you want to know, you hit alpha y equals, and if you have the fraction options, then you know you have this. There are TIs that have this, like the TI, I think 36 has it, but this one does not. And this one is the most popular one. Okay, so what do? We just put it in as is, just as that little fraction looks. I would say 1 minus parenthesis 1 plus, I don't put a fraction in here, it's not needed, 0.045 divided by 12, close parenthesis. This pops me up into the exponent position, so I don't need parentheses. There is a negative button right here, so I'm just going to hit -60. Then I'm going to arrow out of my exponent, arrow down into the denominator, put in the 0.045, divide 12, and I'm going to get the answer of 408.28. I'm also not going to delete this out, because if I delete it out or do anything with it, I'm going to start getting rounding errors. So I'm leaving this in the calculator for the rest of my calculations. So what does this equal? It should say that R equals 408.28. This is the monthly payment. And we'll discuss this more in a second, but I do need to tell you how to do it for a calculator that does not have that fraction, which is what all of this was about. So what did we say? We said start with that 21899.99 divided by, said parenthesis for the numerator, and then start typing in that numerator, 1 minus parenthesis 1 plus 0.045 divided by 12, close parenthesis, caret. Now it didn't pop me up. I'm going to continue with the parenthesis. My negative is down here, -60, close parenthesis, divide, denominator, open parenthesis, 0.045 divided by 12, close parenthesis for the denominator. And now I'm going to get this wacky answer. And those of you who have tried something like this are going to be like, see, I told you, that is really weird, because your monthly payment, if it were, you know, that much money, what do we have? We have 1, 2, 3, 4, 5, 6. If it was $29 million a month, that would be a really expensive car. So here's what's happening, if you want to know, which you probably do. I'm going to jump down to simpler numbers. If I have, let's say I have 24 divided by 6 divided by 3. Well, if I take 24 divided by 6, I get 4, and 4 divided by 3 is 4/3. I'm just going to leave it as a fraction. But in this, we want to divide this back half first. So 24 divided by 6 divided by 3, we want to force that to divide first. We need this divided first. So we put parentheses there. 24 divided by 2 is 12. Those are not the same answer. So this is what's happening. You need this to divide first. In the multiplication, it didn't matter because A times B times C, it didn't matter if you multiplied these two first or these two first. It was all just multiplication. So what we need to do is we need to add another set of parentheses saying, hey, this needs to be divided before it divides into this. One more set of parentheses. So what I'm going to do, because I don't want to retype all this in, is I'm going to hit the back arrow. It's going to put me right back up in here. I'm going to put the 1 right there, and then I'm going to back up all the way to the first parenthesis right here. And then I'm going to hit, see where it says insert right up there? I'm going to hit second, insert a second parenthesis there. Then I'm going to hit equal, and there's my 408.28. So now my two calculators are telling me the same answer because I just added that extra set of parentheses. So when you divide, division is a little more complicated because of how the order of operation happens. You have to force it to divide the second division first. So that is that extra set of parentheses. Okay, to finish off this problem, because I'm asking about interest, we do this payment 60 times. So we take that 408.28, and again, we didn't clear out the calculator. We're doing this payment 60 times. If we do it 60 times, over the life of the loan, what you actually pay for the car. Remember, we took out a loan of, $21,900. What you actually pay for the loan after you pay this payment, you actually pay $24,496.92. So this is what you actually pay because you're paying 408.28 60 times. You actually pay more because this is how the bank makes its money, by giving you a loan. If we subtract off the loan amount, so we subtract $21,899.99, we find out that the interest is $, the answer gets a $, $2,596.93. All right, I hope you've enjoyed this video. Please subscribe to my channel, like my video, and I'll see you in the next video. Thanks.